Okay. So as I said, today we'll be focusing a lot on the arrays, but not just arrays. We'll be also talking about. We'll take some few questions on strings and some and few questions on, like, not questions exactly, but we'll also go through some Boolean operations, which are very helpful sometimes. Using those Boolean operations can save you a lot of space and can save you a lot of time. So we'll use some Boolean operations as well. Let's then start with the first question. Okay, I'm starting with a question. The question is, you have to implement an algorithm to determine if a string has all unique characters. This is something similar to the question we have been solving for last two classes, like duplicate in the array kind of thing. Okay, but it's not array this time. This is a string, which and we have to determine if all of them are unique characters. Okay, and then second part of the question will come later, but we just think about this part. So implement an algorithm to determine if a string has all unique characters. Everyone got the question? So there's a raise hand feature in this Zoom tool. You can use the tool to raise your query and all those. Okay. So the question is, again, I'm repeating. You have to implement an algorithm to determine if the string has all unique characters. So I'm unmuting all of you. I have the control, and then if anyone can use, if you speak. Okay.
So which means in the string has any duplicate characters, it returns false, is it?
Yeah. Yes.
We can convert the string into array, and then we can proceed with our solution.
Okay. So you think you'll convert it to an array by splitting the array into string into character array.
Yeah.
Okay. Okay. What will be the complexity? Time complexity?
Splitting.
What?
To convert it into character array, right?
After that. Come again, I didn't get you.
What we can do, we can convert it into character array, and then we can sort it in n log n. We can sort it in n log n, and then we can again loop over and find the neighbor elements and decide if they are unique or duplicate. This could be one approach. If we can have extra space, we can use additionally the hash map, and then decide if the string has duplicate elements.
Is Sukanya saying something?
Can you give me any example?
Yes. Okay.
Okay, got it.
Okay. So Nitesh is saying you will break it into array and all. Why do you have to do so much thing? Like you can just breaking into array won't add a much benefit to it. You can iterate through each character easily yourself. Why to break it into an array and do something? Whatever you want to do after converting into an array, you can do it without converting as well. So why to convert? Okay. Nitesh?
Yes.
Yeah. Okay. Anyone think so? It's a very basic problem. Just come up with any solution.
So the hash map solution we can use here without converting into array as well.
Okay, so what Nitesh is trying to say is he will iterate through the string He'll go through each character one by one and put that character into a hash map and keep on going ahead till the moment he finds some element is already present. Okay, so what he mean to say is like he will have a loop for I equal to 0 to I less than some string dot length. Okay, that length, and then I plus plus for each element. Nikhil, hello Nikhil.
Yeah, hi Praveen, Nikhil here. Sorry for being late.
Yeah, try not to be late because I have already started and go through the read the question. I have written a question here. We are trying to solve this question. Okay.
Okay.
And also I've given one example, two example. We'll just go through example. Okay. So I'm trying to implement the solution which Nitesh gave, and you all of them can see this. Okay. So what I'm doing is I'm storing everything in my map, and before storing, I'm just checking if hashmap has this already present, then return false, else ठीक है सबको समझ में आ रहा है everyone can see this and the question.
Yes.
Okay, so that this solution will work, and the running time, the time complexity would be Suganya.
But
The time complexity of this solution is
Order of n, I think.
but
Okay,
how
let's
will I
know.
calculate in case of hashing?
What?
In case of hashing, how will I check this complexity calculate?
In case of this is we are using hash sum. This is what we are doing, na?
Yes,
I don't understand. Yes. Yes, say.
Is it one? We are using one loop.
Yes.
So in and for hash for checking it inside the hash, it will be.
Yes. So checking if it is
log
already
n.
present.
So is
So
it n?
no, don't just think randomly. So what we're doing is we are having this loop. Okay, this is the bigger loop. Now for each loop, loop, what you're doing is just finding the character I, which is this line won't take much time. This is order one time. Okay, it's not a loop. Now this line checking if hash map has this key already present. If this is already present, then return false. Okay. Now this operation is also order one. We know from our knowledge. If you don't, we have to know this key,
Yes.
that hash map insertion or finding or deleting, everything is order one operation. Everything is a constant time operation. We don't have to run any loop. So
Yes.
okay, so I'll just try to do this. Any class, any data structure will be talking about in future. Okay, just try to keep this thing in your mind, and if you also possible, note down. So we'll always talk about the insertion method, delete, method, update method, find method, sometime sort elements method. So all these operations in any data structure, we should be aware, at least the basic ones. Array is also one of the data structure. Hash is also one of the data structure. And every time we do these things, we should be aware. So let's talk about array and hash today. We'll talk about rest later. Okay. So suppose this is one of the basic data structure. Suppose we try to talk about the implementation as well as running time. Implementation as well as the running time of these data structures. So let's talk about hash first. Okay. So insert
Praveen,
method. Yes.
yeah, I just have a few questions from yesterday. Should I ask it now or after the class?
No, we'll talk about them after the class if they are not related. If they're related with this topic, we can ask
Okay.
now.
Okay.
Okay.
Yeah, after the class.
Yeah, sure. Okay. So insert method in a hash, we know this is constant time. This does not take time. This is order of 1. Okay. We have to remember this for everything from future. Okay. Implementation we will talk sometime, but delete is also constant time. The way it has been implemented, this is so perfect that everything is constant.
So here it will be big of n,
Yes.
and but here we will have some extra space complexity, right? Since we are using hash.
Yes.
Like
So
you said.
yeah. So given this, we'll not talk about sort now. So given this, we can say, okay. Given this, we can say this algorithm of finding if the array has all unique or not will take constant time. Will take order 1 time. No, sorry, a total of order n. Okay. So because this is not taking time, this is also not taking time. Every loop will doing either this or this, and both of them are constant time operations. Order of 1. Total will be order of n. Is that good enough for everyone? And as Sukanya said, the problem with this, not a problem, but one thing we are doing is we are using extra space. We are using an array of size, a hash with n keys. It will have n keys, where n is the size of the array. Okay, where n is the size of the string. Everyone, okay?
Yes.
Yeah. Now, as we started with saying, Nikhil, you got the question and the solution, everything here from this page, or shall I repeat for you?
Fine, could you please repeat the solution?
Yes. So the question was very similar to the question we have been solving yesterday or as well, I guess. The question was determine if a string has all unique character or not. Okay. This is same. This question is almost similar to the question I asked yesterday, I guess, or day before that. Yesterday, the question was find duplicate if the array contains duplicate element or not. So this is string, and we have to tell if it contains duplicate character or not. Same kind of question. This is string, and that was array. Okay. Now this is 2 example I've given here. This string has C twice, so all the characters are not unique, hence this will return false. But the second one, this string has all unique characters. This means this is true. Okay, that's what we have to tell if the string has all unique character or not. And how did we do it? We tried to go through each and every character one by one and determine if that character is repeated or not. Okay, that's what we do. Like normal brute force approach also would be just let's see each and every character and then try to check. Either we go through each character and then take one more loop and go through each character once again to check. That the brute force approach would be. Okay. So brute again. I'll just repeat the brute force approach. Just take each character one by one and then match that with that character with rest of again with all the other characters. So 2 loops. One loop to pick the element and one loop to compare that with rest of the characters. So that will take order of n square without any extra space. We're not doing anything. We just compare it, taking the current element and comparing with the rest of the elements. That approach would take order of n square. Now to improve, what we did was what we have done here is let's use some extra space. Why to go through each of the character again to check whether this is repeated or not. So what we do is while going through each character one by one. So this is the loop. While going through each character one by one, take the character and check if it is already present in our hash map or not. If it is present in our hash map, this means this is repeated. So just return false. This is not unique. All the characters are not unique. But if it is not present, this means it might be present later. So just try to store that into the hash map for now. So what I did is we have inserted into our the current character into our hash map, so that next time we find this again, we'll be able to determine if this is already present. That's it. Very simple solution using a hash map. And now by doing this, we improved our running time a lot. We came down from n square to n, which is a huge improvement. Okay, everyone okay? Now with this, the only thing is we have to use an extra space of hash map. And if interviewer says no, you're not allowed to, then what will you do? Now comes that thing. You're not allowed. Yeah, it's just gonna tell me.
How do you create this hash map object?
How do you create this hash map object?
Yes.
So depends on language we use. So if I am a Ruby user, the way I created this, that's it. I can create hash map like this. The way Java people will use, there's something called there will be something called hash map of this type. I don't use Java and C a lot, so
it's okay.
Is this how you implement?
Yeah.
Someone in Java will tell me.
Yes.
Okay, awesome.
Here, Praveen, what I could say is instead of hash map, we can use hash set. The reason is hash map, it is going to take key value pair, but we need only.
Yes, you're correct. We don't have to have here hash map. We can use hash set because we don't have key value. We just have value keys. So that's I'm a Ruby user. We don't have hash set, so I just go ahead and use this. Okay. That's one thing you'll have to be very much confident about is your programming language. Okay, you have to be very much confident. You have to practice every single thing. Just by seeing the lines, you should be able to say, okay, this code has this issue and all. Without that I won't be teaching you your programming language, but you have to be very much confident about your programming language. A single thing you can say easily. You remember things easily. You don't have to Google for few small things. Okay, so that will be that I won't be teaching a lot. Okay, so as you Sugandhi, your doubt is clear. We can initialize whatever way you want. Okay. Now going ahead. So my next part of the question was, Nikhil, you got the solution now?
Yes, Praveen.
Okay. Yeah. So next part of the question is, what if you cannot use an additional data set? You cannot use an additional space, or the other way to say it, what I want to reduce the time space complexity as well. What will you do? How will you do now?
We can sort that string.
Sort the string. Yeah. Okay, nice thought, and nice. Good that you came up with this kind of solution. So people try to keep your brain up. Okay, keep on thinking. So even if he doesn't give a full solution now, I'm happy a little bit. Okay, as an interview, I'll be a little bit happy. Okay, this person has few things in his mind. So yeah, he's saying we do not want to use extra space. Let's sort that this string, the character of the string only. And once we sort, we'll have our each same character will be consecutive, and then we'll go through each character one by one, and just compare the consecutive character. Everyone got what you're trying to say?
Yeah.
Okay. What will the time complexity? Nikhil, what will the time complexity of the solution which Nitesh gave just now?
Praveen, I didn't understand the sorting part. Why are we sorting?
Okay, so let me give you one. So A, C, E, B, E. Okay. Let's take F, C. So what will happen if we sort this? what will happen? So it will become A, B, C, C, E, F. Hoga?
Yes.
Okay. Now, once we have sorted, we can just iterate through the string one by one and compare the consecutive element. Okay. Next, I with I plus 1, and then I with I plus 1, and then again I with I plus 1. And the moment we see that I and I plus 1 character both are same, we can easily say that this string does not have all unique characters. This has repeating characters. So by sorting, by processing our input, okay, by processing our input only, we made it simpler to decide whether it has duplicate element or not. I mean, the original input was this, and to find if it has unique duplicate or not, we had to compare with all the others. So the brute force approach I was saying, it take the first character and in the rest of the array, rest of the string, check if that is present or not. Take second character, and then again in the rest of the string, find if present or not. What he did is Santosh left. Okay, so what he did is he sorted it first, so that now we do not have to go through full array to decide if it is present or not. We just have to check the consecutive element, because we know since it is sorted, it will be nearby. Okay.
Okay, got it. So the running time will depend on the type of sorting algorithm, right?
Awesome. So running time will depend on the type of sorting algorithm we use. And from, as I said yesterday, we'll just say we'll use quicksort that takes order of n log n, and we'll go ahead. No one will stop you. Okay. So now tell me, what will the time complexity be using this approach? So first we will sort, and then what we'll do is
N log n.
So n log n for sorting, and when you want to find a character,
Yes.
that will take order of n.
Yes, that will take order of n, because we're just going through each character one by one and just comparing with the next element, and that's it. We're not doing anything else. So that will take order of n. So total would be order of n log n plus order of n, and that will lead to order of n log n. Okay.
Yes.
So it will be order of n into log n, for you to understand this, plus order of n. Okay, and this is, we can easily say this is equal to n log n.
Did we discuss anything, Praveen, before I came? Sorry, I'm asking this question. Anything else?
No.
Okay.
I just told you what I'll be teaching. Okay, just go through.
Okay.
Everyone got this? सबको समझ में आ गया?
Yes.
Okay. So improved. We have again improved from n square to n log n, but I want even better. I want n log n without using extra space. Can you do that? Is there anyone who can do that? I want order of n without extra space. So does anyone remember how did we do in array? Like order of n without extra space. How did we do? याद है किसी को?
Just marking the element in negative something.
Yes. So let me just tell to everyone. So we did this kind of question for array also. In an array of integers, which ranged from 1 to n. There was a special case. That's why we were able to do it. In an array of n elements, n integers, which ranges from 1 to n, how to find if there is duplicate or not. And what we did was, for each element we iterated through, we took that number and we went to that index and made that negative. So this was to mark if someone is if I am present, I must be present in some of the index, and I just made it negative. So I'll just try to write here once again. There was an array of size, suppose 6. The element is 1, 2, 3, 4, 5. Okay. Of size 6. So how can we find without any extra spaces was I went to first index and made I went to first element and just made one index very negative, and then I went to second index, I made this as negative, then I went to 3, I made this as negative. Okay, something I made that negative. So when I reached 1 again, I just saw, okay, this is already negative. This means one was printed earlier. Okay, this is what we did. If people remember, if you do not, we can talk about this question later. But what we did was,
we did this yesterday.
No, we did this in the demo class.
Okay, can you please repeat it?
Okay.
Yeah.
So I will. So how will you find if this array has duplicate elements or not? And I'm giving you the best solution directly. Okay. What we do is we go to each element for I equal to 0, I less than n, I plus plus, and we go to each. So what I did was, what I'm doing is, we just go to each and every element and we take that number and we jump to that index, third index. So this is 3, we go to the third index, 0, 1, 2, and 3. We reached here and we just made it negative. That's it, nothing, okay? And we went ahead. And then we went to 4 and we went to fourth index, which is 2, and made it negative. Then we went to 1 and we went to first index and we made it negative. Then we went to 5 and we went to fifth index and made that negative. Then we went to 2 again and we made this thing as negative. We reached last element 3 and we check, okay, this is already negative. This means 3 was already present, hence it would have been made negative while I visited 3 first. So this decides this array has duplicate elements. Okay, if you do not get this, I'll repeat this after the class for you. Let's go ahead with the current question. So I'm just saying, if you remember this solution, try to think in this way. What we did, how did we? What was the trick here in that solution? Try to think if you can use that trick here. Can we use the trick here?
But in this case, these are strings. How can we make them negative? Do we need ASCII values?
Sure, we cannot. I mean, I'm not saying we can do it directly. This same concept. Can you do something similar? I'm not saying just do that only. My point is, while going through the characters, you have to do something to store that yes, I was present earlier, and to check I was present. Yes, Suganya.
Can we assign true or false value to each of the string while traversing?
What do you mean by assign true or false? Where will you assign true and false?
Just like minus, we were giving them negatives and I'm trying to assign. I'm not sure how to do that.
So what we were doing in array was we were modifying the original elements. We were marking something. We are converting into negative, or we were doing something. So you can do something, but you cannot change from A to true. Like if it is A, then you can make it some capital A something. Okay, but you cannot make it negative. True, false. That is not. It's a string of characters. How can you put a boolean in between a string of characters? Okay, so you cannot do this. What you can do is you can make A to capital A. Can you?
Yeah. Just change their uppercase, lowercase things. Okay.
Something like that you can make.
Yeah, we can. But uppercase and lowercase alphabet strings have different ASCII value. How can we do that?
No, what I'm saying, while iterating through each character, just take the character and convert it into uppercase. And next time when you
Okay, I got your point.
well, did you get the solution?
Yes.
Everyone got the solution?
No, Praveen, Nikhil, yeah, I didn't get it.
Because it's not a solution. I didn't say anything. I don't know how you got it. What did they get? It's not a solution. I was just telling. Yes. So I haven't given any solution yet. I just told you we can mark something by making it capital. What do you get? We don't get anything. Do you get anything? Just making it capital won't work. I was just telling you can do something, and that something can be what that something can be. It can be changing the character. It cannot be make it true and false. Insert in any error. You can't do that. What you can do is just change the character a little bit. We can't do a lot modification like put true false there instead of something else. You can't do those things. Yeah, this is not a solution. Tell me what else you can do.
Here it's like we need to check based on the bitwise. Assume like if we go to A, we need to check, okay, if A is present 2 times, then very starting, okay, we need to set some bit in any of the variable. If again we need to multiply by, if A again A comes in the next value, then we need to check whether the bit is already set or not. If it is set, then there is a repetitive element like that we need to do.
Okay. So people, he is trying to introduce bit operations. Okay, what bit operations means? These kind of operations: 1, 1, 1, and 0, 1, 0. What will the AND of this be? इसका AND क्या होगा? It will be
0, 1, 0.
0, 1, 0. So these kind of operations he's trying to do. So I'll just add here and give you more hints here. Instead of using an extra hash, which is full hash, try to use a number, an integer of big integer, and use the Boolean value of it. Okay, something like I'll just give it. Let's initialize some variable x, which is equal to some big number. Initially, it will be 0, 0, 0, 0, 0, 0 in the Boolean format. This is what it is. Just you can use this. Suppose this is a very long. Can you use this? Vasant, you were almost on the right track. I mean, you might be on the right track as well. So just try to complete your sentence with this input, or someone else you can think how to do this. Use this to mark.
If we know that all the characters are in lowercase, then it's easier. We can map the ASCII value of small a to the first of the element of this bit array.
Yes.
Then it will become similar to the integer problem, and we can turn on the bit or turn off the bit while visiting. And again, if let's say we visited C, and C the third bit is on, that is 1, and again if we get a C in a string and see if the bit is already 1, that means it has already been visited and it is duplicate.
Okay, let me just repeat what you did say, and yes, Vasant and Nitish, both of you are almost correct. So what we are doing is we are trying to use our number, only single variable, as hash map. Okay, as not exactly this is a hash map, but something like what we want to do is every time we visit a character, we try to find which bit should we mark, so that next time we find it again, we'll just check that bit, because bit operations are again constant time operations. Which character is, I mean, we can do most of the bit operation in constant time. So what we do, okay, we have a very simple bit store number whose Boolean format is so good enough that we can just use every bit to store our information if that something was present. So that's so we visit each character. Let me now write here for each. So let's try to. So we just went to the current character, and then we tried to calculate its position, like bit position. Which bit position should be marked something is equal to this current character minus A. Can someone tell me what is this? What will this be? B minus A.
It is like 62 minus 61 means what the ASCII value.
Okay, this is 1. Yes. Everyone, okay. So this is ASCII code. Value of B minus ASCII value of A is equal to 1. This is what at least C people will get this easily. Okay. So by doing this, what we just trying to find which bit position this should be marked. The moment we have this bit position with us, what we do now is we try to make our, let's see, where was that, int x. So we created our entire int. This is equal to, we started with 0, and I was just giving you how does it look like in Boolean. Okay. So now we have our x and make x so what this does is this turns from 0 to 1 at this turns x at this bit position, it changes it from 0 to 1. So before this, we'll just check if x I'm writing okay. Yes, this code, this is similar to our previous code. Instead of using hash map to store or mark or do anything, we are using our simple integer bit positions to mark that position of 0 or 1. And so we just check if it is already 1. This means someone had made it 1, so return false. This is not unique. This has duplicate. Otherwise, just make that bit position 1. Okay. This everyone get this?
Yes.
Anyone who did not get this solution? Nikhil?
No, I'm good.
No.
Praveen, inside the bit function.
I'm good, Praveen. No, I'm good.
Okay. Yes, Santosh.
So what we're doing inside the bit function, what's the complexity inside,
Yes.
and what's the
Yes. Yes. So I'm not expecting everyone to understand this. So I'll just write the modular code. Now we'll try to think what you're doing here. This bit at we're checking if the suppose if x is equal to 0 initially, and then we're checking. So we're checking if this is 1 or not, something like that. How to check this? Okay, this is what we're doing. We're checking in integer x the bit position. Suppose third position is that 1 or 0. That's what we're checking. So what we're doing is, so this is a tough thing. If you have not done a lot of bit operation, it's a little bit tough. It's a little bit tricky. So what we're trying to do is we are trying to find if ith bit position is 1 or not. Okay, that's what we are trying to do. If ith bit position of a number x is 1 or not. So what we do is we can do X and so suppose this is let me say 1, 2, 3, 4, 5, 6, 7. Suppose we want to check if the seventh position in X is 1 or not. If we directly do just AND of these two, the output will be same as this, or it might be this, either this thing only. It can't be anything apart from this. So if that AND is equal to this, then this means X seventh is also X seventh index bit is also 1. Otherwise, if it is this, then this means 0. Do you understand this thing? What I'm doing here? I'm doing AND of X and this special thing to check if seventh bit position is 0 or 1. I am doing AND operation of X and this thing. Now output of this will decide. I can easily say if the AND of this and this is more than 0 or equal to 0. If it is equal to 0, this means everything became 0 because seventh agar X ka agar suppose X was this. Suppose X was this. In this case, if we do AND of this and this, okay. If we do AND of this and this, X and this is X and this is our something. If we do AND of this and this, bitwise AND, so output will be, what will the output be? It will be this. Everything will become 0. है ना, ठीक है ना? Everyone, get this? So I'm using the bitwise operations. I'm doing bitwise AND of it. So iska AND 0, iska AND 0, iska AND, and even this and this in the AND is 0. So this will become 0, and hence we can say yes, the seventh bit position was 0 because I have this is 1, so this has to be 1 to become 1. Otherwise, this was 0. So we can easily say if the seventh character was the seventh bit position, the bit was 0. Hence, this is 0. Otherwise, suppose if this was this. Suppose if our input X was this, and if we do AND, so output will be this. Okay. Now we can say yes. If the output is more than 0, which is this, if output is more than 0, which is this, then we can say yes, the X seventh index was 1. So that's what I'm doing. I can implement that. I can implement this bit checking this. What I can do is this. If I can replace this with if X and 1 shifted by bit position. Now again I'm introducing something. Okay, if X and 1 shifted by this is more than 0. समझ में आया क्या क्या मैंने? I have added one more thing now. Shift operator. Any one of you heard of shift operator? Shift and or सबने सुना होगा? Yes. Okay. So if you have not heard, I'm just doing this now. Shift operator. If there is some boolean like this, if you shift it by 2, this means this will become, these two will go away and only this will be left with 2 more zeros. Okay, ये दो गायब हो गया, ये दो गायब हो गया. This is what shift left. This is shift left. There is something called shift right as well, but this is shift left. So when I shifted this boolean number by 2 position, this will become this. Though the shift again, and we added 2 to pad. We padded with 2 extra zeros. Okay, so this is what shift means. So what will happen if I shift 1 by suppose 3? 1 is like 0 1. Okay, 1 is like 0 1 or 0 0 whatever. Like 1 is this. Not in boolean this is 0 1. Or so what will happen? This if you shift 1 by 3, this earlier it was 0 0 0 0 1. This is what 1 means. This is what 1 means. After shifting it by 3, this will become 1 0 0. Shifting it by 3, 1 2 and 3. Wait. Okay, हमने 3 से shift कर दिया. So from 1 it became this. Everyone gets this? I'm shifting my 1 by 3 positions. This will end up being this. किसी को कुछ नहीं समझ में आ रहा? Raise your hand and tell me something. Okay, I'm repeating again. So I have shifted my 1 by 3 position, and this will become this. Now that's what I've done here. Here. So I'm doing an AND, but before I do AND, I'm just trying to create that bit position one value. This what I've selected right now is being used to just generate my thing which I want to do AND with. The bit position 1 karna, baki 0 karna. That's what I'm trying to generate. Okay. And once I've generated that, I'm just doing X and that thing. If that is more than 0 or equal to 0, more than 0, this means X had 1 at that thing. If it is equal to 0, then it means that the bit position was 0. Hence, we'll have to set it to 1. And this is like setting. This is like setting it to 1. We'll have to write code for this as well. Turn on. But before I write for turn on, this was for bit checking what if that bit positions bit is 1 or 0. Okay. ये समझ में आ गया आपको?
Yes.
Okay, nice. So now this thing, let's try to someone you people try to write code for this. But what do I mean is given x and the bit position. Okay, I want to make the bit position in the x equal to 1. I want to make it 1. So how will you do it? By doing your bit operation. You have to do it using bit operations. You have been given x, so let's try to write the very simple question. You have your this number, and I want to make this as 1. What will you do? Just want to convert this as 1. Okay, this is the input number, and this is the index which I want to convert to 1. What will you do?
So what I'll do is I'm going to take 1 and just shift it by 3, and then add it with the previous value. So
okay, so you're close. So what you're saying is, so using this 3, first of all, I'll generate my something like this. Okay, this is not third, this is second. Let's suppose this is 0. Okay, so using this, what did you shift using 3? You'll try to create something like this. How will this be created? This will be like 1 shifted by 3. You did this, and then you got your this thing. Once you have this, what will you do?
Summation with the previous value. Yeah.
Yes. So what we'll do is we'll do a bitwise OR. Okay. यहाँ पे हमने किया bitwise AND. This was what was this? This was bitwise AND. What we'll do is now with this thing generated, which we generated by shifting 1 by 3 values by 3, we generated this. Now if we do bitwise AND, what will this return? This will return the same thing, exactly same thing. Just this thing will become 1, and that's what we want to do. है ना? यही क्या करते हैं हम? So we just turned the third position from 0 to 1. That's what. So this is what we did here. Turn on. Okay, let me just write this. So what we did is else x bitwise OR else x bitwise OR with what? With 1 shifted by bit position. Okay, we changed our x. We just did a x or 1 shifted by bit position, and this is how we marked at bit position. We changed value from 0 to 1, and we marked for our next iteration. Whenever we just find that bit position again, we'll check. Oh, it's already 1. This means someone had made it 1, and we got that this has duplicate. Then में आ गया. Everyone got this?
Yeah.
So what did we learn today? Special thing. Apart from the 2 normal things, was the special thing we learned today is bit Boolean operations. So go ahead. I might be able to share something also, but try to read a little bit about bit operations. Why this bit operation was very useful here? Because just using one integer, just using one number, we use that as same as our hash map. Like we didn't have to create a big hash map to keep a like checker. It's like checker. We have a checker, and we don't have to initialize a big hash map. A single number would have is enough. Just and why is that enough? Because we know our ASCII value has a range. It won't be bigger than some value. So we can use some integer which has some size, whose boolean will be of like 64 bits, 64 bits or 32 bits depending upon the system. But we can use the 64 places and we know our characters are only 26, 25, whatever. So we can use 64 size bit value of integer. Okay. So read about this bitwise and or XOR. XOR is also very interesting thing. Lots of problems will be solved by XOR. At least I'm sure we'll face someday. We'll get a question where we'll use XOR, and this is very interesting to use XOR sometime. It's very tricky and it solves lots of things very easily. Okay, so learn about these and or XOR and your shift. Very important is shift also. Shift, if you have not used, learn about using shift as well. So just try, note some. You people note somewhere. I'll be just talking about this thing in the next class once again. But okay, but you have to read yourself. Moving ahead. I'm moving ahead. Okay. Okay. Next question. Write a method to decide if two strings are anagrams or not. You know what is anagrams?
Yeah.
Okay. Anyone who doesn't know what is anagrams? Okay. If everyone of you knows what is anagram,
I don't know what's an anagram. Does it mean the same string? Does it mean the same?
So this and this is anagram. So anagram is like just different combination of the string. Okay, all the characters. Just that's it.
Okay.
Who is giving me solution apart except Vasant and Nitesh? Who is giving me solution here? Yes, Suganya, tell me.
Can we just take the alphabets and the count of each of these alphabets and compare between the two strings?
Awesome. So what you're trying to say, just keep a count of each alphabet and at the end just match. If the count is same for both of the string, we will be able to decide if it is anagram or not. If it is same, it's anagram. If it's different for each, so we are maintaining a character count. And how where you will maintain the count?
I have to take one array.
Okay, array.
And then I will store the count of A, B, and C for the first string. And in another one, we will store the count of B, A, and C for the second string.
So for this, you'll have an array. You'll have count for each A and B and C at these indexes, and then second array, also one more array, and this also will initialize with 0, 0, and then we'll count for each again A, B, and C.
Yes.
And then you'll check if this is equal to this, this equal to this, this equal to this.
This is.
Okay. I'll have more questions, but before that, other people, do you get what C is trying to say and what is the small mistake C is trying to making? Do you get?
One solution. Hello.
Yes.
Praveen, if we reverse the string and keep it in one temporary variable, and we can verify.
What coming if you reversed it?
Reverse a string and store it in one temporary variable, and we can match the strings whether both are equal or not.
No. how will reversing compare it? So this is your input string, input 1, and this is input 2. If you reverse this will become C, B, B, A, B, A, and then you'll compare this with what?
Okay.
You compare this with, I'm not talking about palindrome. Okay, I'm not talking palindrome. This is anagrams. Palindrome is what you're talking about. You reverse this and then you compare. This is not palindrome. So this is again a very strict, not strict, but very bad thing as an interviewer. If you try to guess solution, or if you try to just use random things in random positions.
Oh, Praveen. Hello.
Yes, Nikhil.
Yeah, Praveen, like, can we just, so anagram is what it means, different combinations of the same, this number of letters, right?
Yes.
So say we try sorting it. So the number of times we take to sort, we'll get at one point of time. Say we are sorting 3 B's in a string. We'll also have to sort 3 B's in the other string. So that way we'll get some value out of that.
Okay. So I'll try to talk about your solution. Before that, I was just completing. So Santosh, if you this will take time, but let's not. I mean, try to avoid these things. You have to use seriously. Okay. I know this is like your thought process, which you have to be louder as well. But sometimes that ends up being negative. Why is he doing bringing the palindrome solution in anagram? Just because he read palindrome doesn't mean he insulted everyone. This happens. I have seen this in multiple interviews. People sometimes use hash map unnecessarily. Just because they have read a lot of hash map, they end up using hash map in every solution. Just because they have read trees, they end up talking about trees in every solution, which will go a lot negative. So be careful a little bit. And again, this requires practice. And therefore, okay, coming back to Nikhil's solution, he was saying, and also we'll talk about Sukanya solutions as well. So Nikhil was saying sort. So what he's saying through time says, just sort this string character wise. What will this become? A, B, B, C, B, 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 C, and sort this as well. So even this will become A, B, 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 C, because, and then compare the sorted value. So we have, the question was, write a method to decide if 2 strings are anagrams or not anagrams. And it was string A, 1, and string 2. And we have to decide if string 1 and string 2 are anagram or not. What he's saying, sort. Just sort string 1. Okay. And also compare this with sort string 2 also. Sort both of them and check if both of them are equal. This means they were same as anagrams, because sorted of both anagrams will be same only. That's it, nothing else. Just sort both of them, and after sorting, if they are equal, this means string 1 and string 2 both of them were anagrams, and hence sorted value will be equal. A simple solution, very very good. If you thought right now, Nikhil, this is good approach. You should be able to think this. Right. Okay, awesome. So next, coming to Sukanya. Sukanya, you are saying we will keep a count of each character somewhere. Okay, somewhere. I mean, you have initialized an array for this. You are again on the right track. Instead of that, why to take 2 array and all? Just take why 2 space, waste 2 space. Just again, you can have a hash map. Something we have been using to do. Okay. So what we do is, every time we get a character, we will increase the count by 1. Okay, of that. If it is present, then increase the count of that. So it's key value now. Now it's key value, because that time we could have used hash set, but here we'll use key value pair, which is hash map integer. So, and what we do is, we go to each of the character in string 1. We check if the character is present or not. If it is present, just increase the value. If it is not present, then just insert that value with 0 with 1 count. Okay. So at the end, we have our hash map. And while iterating to the first string 1, we will have a hash map with character count of each character. Okay, we'll have the count of each character. Now we'll go through string 2 as well, and in the same hash map, we'll just decrease the count. If it is already present, just decrease the count. At the end, all the count would be equal to 0. all the character. If anyone is like negative, this means negative or positive. This means this character was present in string 1 but not present in string 2. Or if this character was present in string 2, not present in string 1. But if everything is 0, this means all the character was present in both. Okay.
Praveen,
Do I
Praveen,
want? Yes.
I just got disconnected. Could you please repeat Suganya's solution?
Yes. So what Sukanya was suggesting ki we will maintain some count somewhere, count of the characters. Ki, okay, let's take string 1 and A is present. So let me just sorry. Yeah. So take the string 1 and how many times A is present? 2 times. So maintain A equal to 2, B equal to 3, and C equal to 1. We just maintain it somewhere and compare the same thing with string 2 also. How many times A is present, how many times B is present, and how many times C is present. You have to maintain this. To maintain this, Sukanya was trying to initialize two separate array, which is completely okay, but not the best one. We can use a hash map again instead of initializing two array, a single hash map, which will have each character as a key and the value as a count, how many times that is present. So go through this string one by one. A is not present, so A will insert A with count 1. B is not present, insert B with count 1. A, oh awesome, A is present, let's just increase the count of A to 2. B is also already present, increase the count to 2. B is already present, increase the count to 3. C not present, insert C with count 1. At then we have A equal to A values 2, B values 3, C values 1. Now go to the string, second string also. Again, second string, just try to decrease the value. Okay, A is A present or not? Make it insert that and sorry, no, don't insert. Just decrease the value from 2 to 1. A already present, make it 0. B already present, make it 3 to 2. Then 2 to 1, 1 to 0. C make it 1 to 0. At the end we'll have again A, B, C with count of each of them is 0. अगर C ज़्यादा होता, अगर C एक और होता तो finally C would have become -1. और अगर C होता ही नहीं, then the C would have been still just 1. In both the cases, we know these two are not anagrams. Okay? समझ में आ गया?
Yes.
Anyone who still is not getting this solution? Awesome. Moving ahead. Next question. This is a good question. This question was asked to me 5 years back when I was in college. And I think, yeah, I solved it. So this was a question asked to me by Microsoft 5 years back when I was in college. Write a method to replace all the spaces in a string with percentile 20. Okay, just if you know the meaning of percentile 20 in URLs, if you see percentile 20 is the URL encoding for space. For space, we replace that with percentile 20. Anyways, so not very much use here. The only thing is we have been given a string. Praveen is teaching DS. So we have the string and we have to replace these spaces with percentile 20. Yes. Got the question?
Praveen.
Yes.
Hello. Yeah, when I'm saying space means it is a null value, right?
When you space, why you say null value? How is space and null value same? What language do you use, Nikhil?
No.
What program?
Usually I use Ruby.
Ruby. Oh, how can you say this? Ruby user, how can you say this? Is this equal to null? No. Is this equal to null? No. Anyways, yeah, go ahead. So people, if you have the solution in mind, tell me. Otherwise, you have some time. Try to write on paper and try to write on laptop if you have. Try to write whatever space you have, and think and tell me the solution, or also tell me if you found the problem with the solution, because I'm sure you'll give a solution and then you should be able to tell yourself, okay, this solution has some problem, we can improve. If you're not able to tell the problem, I'll tell the problem, but try to think.
Praveen, I am having one solution in Java.
Okay.
So what we do, we can split the string into a string array by giving the delimiter as space.
Mm-hmm.
So we'll get the string array. So while iterate, once we get the string array, then we can iterate to each string and we can append that %20 into, and then we can make a complete string again.
How will you make the complete string? By joining, how will you join arrays? So
Each element we can
that.
Each element we can traverse, and we can maintain one extra memory like string buffer and all, and we can add that into and make it as a complete string.
Works. That will work. And since we're using a normal array and all those, we can do this. Now comes the constraint. You cannot use extra space. I mean, you can use one more variable, the output string, but you cannot use extra space to do this. Okay.
Mm-hmm.
One more variable.
And also, like you cannot use those awesome operations of Java and all. Key split string, join. I mean, join to three is okay, but split, and all those things are not allowed to be used. Yeah.
No, next you said that we can use one more variable. Is that string array we can use it?
So what would come again?
No, you said that we can use one more variable. That means can we use string array?
No, string array. Array is again, I mean, you can use string array if it is in the range of one or two size, three size, but given input size is this. Okay. I mean, whenever you think how much can we use? So if this is the input, we didn't do a lot of practice this time. If this is the input, what is size of the array? What is size of the string? Suppose this is equal to n. So you can't use something of any array of size n, because that will mean if you use some array of size n, that will mean using extra space. So you can use extra space, but you cannot use those spatial what is that? Spatial operation. You cannot use those things. The spatial operation split and all. You can use extra space. That's not a problem. We'll give this restriction later. But current restriction is you cannot use split and all. Yeah.
Okay. What I will do once I iterate, then the first string I get to know how many spaces are there, empty space. Okay.
Okay.
So
okay.
Another string array, I'm going to initialize with. I'm going to add. Okay. For example, I will get to know 4 spaces are 4 into multiply with 3 means 4 multiply 3 plus what is the total count? Total. Just 1 minute. 4 multiplied by n minus 1. I will do it. Sorry, 4 multiplied by because I need to add 3 spaces now, because %20 it takes 3 spaces. So because empty space consumes 1 space, now we need to add replace each space with 3 more characters. That means each 1 space is going to be now 3 more characters, like Praveen *20 instead of Praveen space.
Yeah.
So I have to calculate the size, the new size of the array. Once I calculate, then I have to iterate the current string once I get the space, empty space, there I have to put *20.
Okay, so you know the length of the new output string. Now what?
Okay. Next I have to, okay, once I get first I need to find out how many spaces I need for new string.
Yes,
What is
Sukanya, Sukanya, I'll come to you. Don't worry, I'll come to you. Yes.
Hey Praveen, Nikhil here.
Just wait. Let him complete. Vasant, go ahead.
Okay, first initially length is n. New length, it becomes n plus. Next, the space, if I consider, okay, 2* num into space, that's correct. That is the size of the new array, new string.
Okay, after that?
Yeah, now I'll iterate through new length. Okay, so now I'll iterate the given input array. So I'll assign each character into the new array.
Okay.
Whenever there is a space, that time I'm going to put *20. Sorry, %20.
Okay.
So once I put %20, then I have to increase the index. No. Now here I'm going to take one variable that is initialized with, assume the outer, here it is only one loop for int I equal to 0. Inside I'm going to take one more j, where I initialized with 0 equal to 0. That j is for new string, and that I, whatever the loop, for loop, that is going to be for the given string.
Okay. So I'll talk about your solution, like what you just told. Nikhil and Sukanya, one of you. Okay, Sukanya, tell me, what was your question?
I typed something in the chat. If
Yes.
I encounter this space in null type, then can we replace that thing with %20?
I didn't get.
I will traverse it. Yeah, tell.
So you have written n equal to this null operator.
Yeah. So if this is only how we mention space, right?
Yes. Okay.
So if I encounter this, can I replace that plus with %20 in C
Yes.
language?
Okay. And if you replace
Yeah,
this with
Praveen, I meant this.
what?
Initially, when I meant null, I meant this. Ahead.
Okay. Sorry. Yeah. So Sukanya is saying that you will replace whenever you find this, you will replace with %20.
Yes.
Will you create a new string, or will you do the same string?
New string.
Okay, so you have a new string. You're going through each character one by one. P, you add P. R, you add R. A, you add A, and you keep on going until you find a space. The moment you find space, the moment your character is equal to this /0 whatever space, you type %20, and then you again keep on going ahead. Is that what you're trying to say?
But there's a problem here, I think, Praveen. So,
What?
This null occupies only 2 characters, I think, but %20 is occupying 3 characters. So we can't fit.
No, so that's why we have initialized our new output string with a new size. So if old size was n, our new.
Yeah, that.
Okay. So
yeah, that right. We will have to do.
You're right that we can do this very simply. We just initialize a new string and we know the new length, and we just take one by one each character and we replace in the new string one by one, and the moment we find space, we just replace the percent 20 and we go ahead. That's it. It will work. Now comes the main part. In space, you have to do it in space. You have to use the same string. You have to use the same string only. You can change the length of the original string. Okay, you can change the length of the original string. You can append lots of spaces at the end. You can do whatever you want, but you don't have to use. You don't have. You can just change the same string. Don't create a new string. Do it. Change the same string into the new string instead of creating a new string. That's what the main question is now. What you said, Sukanya, is good. It will work. But this is a special problem where I'm saying is just change the original string to the new string instead of creating a new string. Now comes the exact the main problem. Will your so suppose what we do is we have our original string.
Praveen,
Yes.
Say we iterate over the string with the new length, and we replace that space with that value.
And after that.
And similarly, then we reverse the string, and we do it similarly.
Do you see the problem? What do you mean with similarly? There's a problem with doing similarly. This small problem, Vasant and Nitesh. Do you see the problem in doing it in space? Again, in space, we are not getting another saying. If you're doing the same thing, same algorithm which we just told for the past solution, do you see a problem with that? What is the problem with doing that? अगर अपने original string के space में हम if we replace space with percentile 20 in the original string only, then we'll end up overriding few things. So suppose we found the first space, P कुछ नहीं किया, R कुछ नहीं किया, A we didn't do anything, V we didn't do anything, double E we didn't do anything, N we didn't do anything. The moment we found the first space, oh awesome, we found it, let's override that space with percentile 20. The moment we do that, we'll end up overriding IS. In the space of I, it will become 2. In the space of S, it will become 0. So we'll end up overriding our original string, which we can't do. We can't lose the original string. So yes, that is a small problem with doing it in space. If we had new string, then it was very easy. P के जगह P, R के जगह R करते गए, जैसे ही space आया, we just replace it with percent 1220. We went to next I and then we did it. But if we do it in space, we do not use any single, we do not create a new string, that will be a problem with the same approach. है ना?
Yes, I have another approach to overcome this problem.
So you're saying you have another approach. First of all, we know this is the new length of the is going to be. Yes. Now go ahead. This is the new length of the string going to be. Yes.
So we can figure out like what is the extra space required, and we can increase the length of the current string. So,
yes.
So at the end we have extra blank characters which we can use.
Yes. So suppose we found that. Okay. We have this original string. We have this original string, and with this original string, what we do is we iterate through this and find the number of spaces. The first thing we found is number of spaces. We just iterated and we found the number of spaces. The moment we have number of spaces, we know the new length is going to be this. What do you do after this? And after we have the new length, we convert our string to something like, we add extra spaces. That's it. Okay, this is what we do. After this, what do you do after this? We have our new string whose length has been increased, and we have just appended spaces right now. What do we do now?
So that will be 1, 2, 3, 6 extra spaces, right?
Yes, 6.
6. So I'll explain my solution through the example. So
okay.
What I'll do, we'll pick the last element, the S, and shift it by 6 spaces.
What? Shift by 6 places?
Yeah, the S will move like 6 spaces. No, we'll like move it. The 6 will go at the last place.
This?
Yeah, correct. Then
Okay.
we'll do the same with the D,
Mm-hmm.
and then when we encounter the space, we'll put the our percentile 20.
Okay.
Now we have covered one space. So next time we'll not shift by 6, but we'll shift by 4
Mm-hmm.
for rest of the characters.
Okay.
Yeah, so the complete teaching will be shifted by 4. Then we'll
Okay.
put then we'll put percentile 20.
Okay.
Now we'll shift by 2, and then we'll put percentile 20, and it should cover all the spaces. Yeah, that's it.
Everyone got what he tried to say, and how did you do it?
No, Praveen, I didn't get it.
Nitesh, can you repeat what you just said?
Yeah. So first thing is that we have in our example three spaces, and we have to replace each space with percentile 20, which is 2 extra character each space. So what Vasant said is the same, like number of spaces into 2. So we need like total in our example 6 extra spaces to occupy percentile 20, right? Percentage 20. So first we are adding that 6 extra space to the current string. Now,
Okay.
now we know that every time we replace space with percentile 20, it is going to require extra 2 spaces. So, and we have like total extra 6 space. So we'll start from the
But
end.
it extra. But if we replace with percentage, when it's going to require 3 spaces, right? Each character
Yeah, but
requires 1 space.
yeah, correct. But the space we already have, so we can use that space. So actually, two characters will be extra, right?
Nikhil,
It's like
so you have to
3 minutes.
replace space with percentile 20. So you already have one space. You need two more. Okay. You already have percentile space is 1. Percentile 20 is
Okay,
3.
yeah.
So
Okay. So let me just repeat once again. If those who have not got it for them, otherwise we'll go ahead. Okay. So what I'm trying to say, what he's trying to say is we need more spaces. Also, we agree. How much more? And we all know by mathematics or the count of spaces, we know this much extra space we need. So we just increased our input string by that much. Okay. We just appended that many spaces. And why did we do this? Because we know our output will be six lengths bigger because we have 3 spaces, so we just increase it. Now he's saying so the problem with doing from front here this side was if we see this space, if we replace this by percentile 20, so solution initially which you gave Nikhil was replace space with percentile 20. The moment you say okay, uh, this string of 0 is equal to p, don't string str of 1 r, don't do anything, str
No,
of
Praveen, what I meant is,
yes.
I said if we I said we have to reverse it and then do this. So when we reverse it, those extra spaces which will be there will be already put percentage 20. So we reverse the string.
Reverse what? Reverse this or reverse this?
No. Yeah,
This
reverse the extra one.
this
The
one?
new length.
Okay. So once if I
Yes.
reverse this,
Then all the spaces will come in front, right?
okay, someone reverse this for me. I can't. Okay. Okay, reverse using my IRB. Yeah, I reversed this. Now what? Nikhil, I reversed. Now what?
Now we can replace those starting wherever we find that space, we'll replace with percentage 20.
So this is the space. I'll replace all these spaces with percentage 20. So this will become.
Yes.
I don't know why you're saying this, but you are saying replace. Give me a second. I'm doing what he just said. Writing a. Yes. So by your thing, what I did, I just replaced, and this is what it became. Did we want this?
Say now. One sec. Reverse.
Okay, you just. I don't know why you're saying this, but there is no use of reversing and all those things. And also, if you reverse, it might do something, but we don't want to replace this space with percentile 20 first of all. Okay, this is the space we use for our purpose. These are the spaces which we want to replace, and not the one we just appended ourselves.
Praveen, can we say we get rid of that space now? That initial space, instead of replacing that initial space, can we get rid of that extra space?
So this is what will become. Do you want this now?
Yes.
No, we don't want this. We wanted this. Not that.
Now reverse it. After doing this, now we reverse it. Okay, but then that 20 will become 0 to 0.
And that is one problem. But that is not only problem. How did you replace that thing? You haven't told. We just said we will replace, but the replacing would need something. Okay, we're not discussing this. We can discuss this later with you, Nikhil. Why it is not working. But let's go back to our own thing. So we have this appended string, and we want to replace each space with percentage 20. But the problem with doing it front to end, like start to end, is the moment we find a space, we cannot just say, okay, str of 7 equal to percentage 20. The moment we say, so suppose we have the loop str of 0, we see it's not equal to space, so we don't do anything. Okay, it's not because we don't. But the moment we see, okay, the str of suppose some I and x, oh, this is equal to the space. So we can't do this equal to str of I equal to. We cannot replace simply. Why? If str of this equal to space, we cannot do this simply. Why? Because the moment we do this, it will override I and s. So if we do this with, so this will become percentile 20, and it will override our complete string. So, but we don't want that. So what we have to do is first sift everything. You have to sift everything to the right side, and then you make space for percentile 20. So what you can do is, instead of just replacing by simply str of I equal to percentile 20, what you can do is first sift 1, 2, sift this, and then you have the space here, and then you can say, okay, percentile str of I equal to percentile str of I plus 1 equal to 2, str of I plus 2 equal to 0. Then you can replace. But problem with that also is that, like, you have to shift every time. That's why Nitesh gave another solution. Let's not go from front. Let's try to go from back only. So what Nitesh was saying, so this is after appending space. Now what we do, anyone has a question? किसी को समझ नहीं आ रहा? Okay, so I'll go ahead. So what I'm trying to do is, what Nitesh said is, instead of going from front, go from back. Okay, but he also didn't give a perfect solution. In his solution as well, we have to do a lot of shifting. I mean, if we are shifting, we could have done the shifting from this way only. The problem with shifting is time complexity. I did not say this to you, but you should have thought yourself, what is the problem with shifting? The problem with shifting is time complexity. For every insertion of a space, we have to shift full string. Okay, for every insertion, we have to shift full string. So the time complexity would be, let's just try to calculate the time complexity of this solution only. We'll come to the better solution later. So the current solution which is append spaces at the end, and then for every space for every time you find a space, try to shift the string 2 by 2 and then insert percentage 20 there. What will the time complexity be, Suganya?
For each time we are checking this, yes. For each time we are checking the spaces, it should be n.
Okay. Okay.
So it is order of n only.
Order of n. So we are iterating through the string one by one. So that is one by one. That is order of n. For every time we find a space, we have to shift also. So suppose in the worst case we have lots of spaces. We have like n by 2 spaces. So for every shifting we take another order of n. So it will be n into n by 2. Like we are shifting it n by 2 times. And every time we take suppose n space. So we're doing this. So let me calculate for you. So we had, first of all, our external loop will be go to each character and check the space, and then for each space, suppose there are n by 2 space. Okay, for each space we do shifting n by 2 times. We're doing shifting. So every time we do like shift some characters, so it will be n into n. It will be n square. Let me repeat. So we have this external loop for I equal to 0 to I less than the size, जो भी है length, and then I plus plus. For every time, what we do is we shift. Whenever we find a space, we shift and then we insert. So shift. How many times are we doing the shift? And this shift will take you order of n. We have to shift n characters. This shift is taking n time. So this loop runs n time, and every time we find a space, we do a shift. And suppose we have like lots of spaces. So suppose we have all the spaces only. So we have n into shifting time, which is again n. This is order of n square. समझ में आया? We are shifting. The shifting is the cost you order of n. So we are shifting like so many times. Suppose 3 times, 4 times, 5 times we are shifting n by 2 times. So it is like n into some number of spaces, which is in the range of string only. So it is order of n square. That's why we want to improve. By doing the normal solution, like find the space, shift the character, we can do it. It will work, but we do not want to do that much work. So that's why there is a trick. The trick is do the same thing, but try to come from back instead of front. How is that going to help? Think. How is that a helpful thing? Think. But what Nitesh said, I don't want to do shift, because अगर shift करना ही है तो शुरू से ही कर लेते हैं. If you want to shift, then do the normal shifting from front side only. Why to go from back if you want to shift? Because shifting will anyways take n time, and you're doing for each character on a space, it will take order of n square. So my point, my tip, my simple hint here is try to come from back.
Praveen?
Yes?
My solution will take O of n, right?
No. How are you saying? What you said, you will come from back and you'll shift your D and S to the end. The shifting, how will you shift that? That shifting is going to take you n time. Then again, you'll shift complete teaching from that to the end. That shifting will again take some time. You're shifting every time.
We will have array index of the array, right? Like we know that we have to shift 6 times, so we'll know that we have to move it like from current position to the plus 6 position. So that can be done in one point, right? Shifting means like we'll just copy it. We'll not actually shift it.
Let me think. So you're saying you just copied. So you went from back, you copied D to last person and S to last person. Okay, that is what you said.
That is
Okay.
that is like a constant time, right? We will just put new character at that index of the array.
Okay. And the
And then
moment
we
you found the space,
yeah, we know that on which index we have to put percentage 20.
okay, I think he is correct. Let's not tell. Let me tell you what we are trying to say. So what we are saying, we maintain two integers. We maintain two indexes. One at the last of the array, and one from here. Okay, so let's maintain two indexes. One index is
We don't need even two indexes.
no. Let me tell you why we need this. So let's maintain two indexes. I equal to the new length, and let's use let j equal to old length. Okay, so what we're doing is we are coming from back. Okay, we're coming from back, and we have two indexes maintained, one at I and one at j, and we just check. We just copy from the value from jth index to ith index. So we just check.
Yeah.
Oh, what is the value at jth index? Is it normal thing? Yes. Just copy s to end. Next, go to d. Just check what is value. Is it space? No. Just paste s to end. So what this will do is this will become okay. Does this
Yeah.
next? J started from here. We have just moved two index. We have not done anything. We have moved j equal to j minus 2 and I equal to I minus 2. And by doing these two steps, we just copied ds to here, nothing else. We have not done anything else. Now we see, okay, at jth index, we have a space. What to do now? We have a space, and we don't want to just simply copy space here. What we do now, is the time when we write percentile 20 here.
Yes.
Got it?
Yes.
Sakusanya, what you did? So I'm coming back. I'm coming from the end. I'm maintaining two indexes. One at the old. Yes, Sukanya.
I didn't get you why you replace the three spaces with percentile D. All of a sudden, how can you do that?
Okay. So I'll start again.
Yes.
Okay. So this is our input string. Okay.
Yes.
And I have my index I at this place. Okay. When you see the marker, I have my index I at this place and index j at this place. Okay.
Yes.
So I compared, I just checked what is the value at jth index, and that was s. It was not space. So my algorithm says if it is space, do something else, but if it is simple, just copy that to this index. So I have my string. Let me write the code only for you. If str at j, you know what j and I is. I have just initialized this here. Let me copy that also here. So I have my if str of j is equal to okay, is not equal to, let's do not equal to space. If it is not equal to space, simply do str of I equal to str of j. I'm doing this, and I am reducing I equal to I minus 1, or let's do I minus minus, and j minus minus, and this is while I is less than I is more than 0. This is I is more than 0 equal to 0. Okay. And we are working for every time else if it is equal to space. That is the interesting condition. If it is equal to space, then str of I and str of I minus 1 and str of I minus 2, these three things will be replaced by something.
Okay, but percentile 20 is a 3 variable space.
Yes.
Okay.
Everyone got this? Maya, what we're doing? Yes, tell me.
The question is, I'm not getting clearly how come checking from the back is helping us to reduce
Yes.
the.
Yes, how it is helping when we are doing from front, we had our the moment we found first space, that is this, the moment we found this space, what will you do? Tell me, what will you do to make it percentile 20? You'll do something like the way I have done this: string of I equal to 0, string of I minus 1 equal to 2, and string of I minus 2 equal to percentile. What will you do if you do from? What will your code be? It will be something like str of I equal to percentile 20, str of I plus 1 equal to 2. Str of I equal to percentile, str of I plus 1 equal to 2. Yes.
I will try the first one. All of a sudden, I will write stri equal to percentile 20 instead of writing it separately percentile.
Okay. Yes, and do you think what will that do? What will that do? Will it make it? Santosh, you answer this to me. She said she will make str of I equal to percentile 20. What will this? The output of that thing will be this, or it will be this. What will that be?
That will override it.
Okay. So Sukanya, so if you do that, str of I equal to percentile 20, it won't just insert into that and move this. It will just override is. Is will be lost. You're gone. Where is your is? So that's what. So how could we solve that? By shifting first. But shifting is costly. So that's why come from back. We don't need any shifting, and we don't even have the problem of overriding as well. We know we are coming from back. Our I will always be bigger than our j, because I is getting subtracted by 1, and j is also getting subtracted by 1, and j is I is bigger. I was like original length plus 2 into number of spaces. I'm just sure I will I will never be less than j, so we won't override ever. We'll just keep on coming from the back. We will never override. We'll just have enough space, enough count to override. Okay. Okay, does this make sense?
Yeah.
And also think like what we did here is we tried to think the problem first was replacing overriding. The second problem was space, and after we have to solve both of them. We cannot override. We don't want extra time. The shifting time. Shifting is always costly. I mean, we don't want to do unnecessary shifting. That's why we came from back. Okay. So today's class is mostly about tricks, little bit about tricks and things. It looks as a trick, but actually this is what you have to be prepared. So you have to solve so many tricky questions that you're prepared for it. I have not taught you a lot of theory today, but arrays don't have enough theories as well. Arrays mostly you have to understand the questions, and this will be beneficial. Okay, we have covered most of the topics as well in array. We also covered a little bit about bitwise operations, which is a little bit of theory we have to know, and which you should have known by now as a computer science engineer. But that's okay. Now, but you have to go through the bitwise operations a little bit yourself. And then what we talked about was what we can talk. We had done a few questions. Let's do one more then. Shall we do one more? Ek aur kare?
Yeah.
Okay. So before we do one more, let's just talk about string a little bit, because that is one of the most primitive data type, and we should be aware of the methods. We should these are very basic things. You should always be ready with these. Okay, iske insertion ka agar karne ko, if someone asks me how much time does insertion in array takes, how much time deletion in array takes, how can we insert anywhere, can we insert someplace, those things you should be aware. So let's just do this. It won't take much time. We'll do these methods in very deep for other structures like tree and map and everything, like heap and everything. But the array we won't do a deep analysis. But yeah, insert, delete, update, and find, and sort. Few things we'll talk about. Let's talk about insert. So actually array is so commonly used that you don't think that as a class, okay? But it's a class with so many methods already that it gives you support of these things. A of 0 equal to something. So this is actually inserting into array. Okay, this at the backend. What it doing is there is an array object A, and you're doing is A dot insert something at 0th index. This is what it means. This line means this only. है ना? So we should be aware these methods, these instance methods, which is somehow implemented internally, how much time complexity what is the time complexity of these insertion all. So can someone tell me what is the time complexity of inserting into an array at index, some index? It's constant time. We know we don't have to do a lot of things to insert into an array. We just mark that value or something. Okay, so this is order of 1. Delete. How much time does it take to delete an element from an array?
O of 1.
O of 1 is people do everyone agree? Does everyone agree on this? O of 1.
O of n. We'll have to find the element in the array first.
So delete element. So element.
If we know the index, then O of 1. If we don't know, then we'll have to find it and then delete it.
Okay, so let's talk about delete element. We do not know the index.
Yeah, then O of n if index is not known.
Okay, people. So he's saying delete element will take order of n. Why? Because first we have to find. Let's talk about find only then. Forget about delete. How much find element will take?
In the worst case, it takes n.
Order of n. Awesome. So finding element in an array where we do not know anything. It's a simple array. It can contain it can contain sorted numbers. It can contain only numbers for 1 to n, but it can be random. In case of random, which is the worst case, we have no other logic but to go through each element one by one to check if it exists or not. In that case, the complexity would be order of n. Okay. Now delete. So delete will first of all you have to find only. So it will take at least order of n, then plus deleting. How much deleting will take? Suppose you have found. Now what?
No found.
Now what is you have to make that a of that index equal to null. But by doing this, you will have a null in between. So you have to sift every element after that to one side, one left. So you have to do some sifting as well. So it will be another order of n. So total will be order of 2n, which is equal to order of n. Okay?
Okay.
I mean, you can delete and leave that as null, which is not a problem. But people normally don't want to have a null element in between. Hence, we have to do shifting. But anyways, whether you do shifting or not, it will be order of n. Got it? Update. How much is the time complexity for update?
O of,
Update.
if we know the element.
Yeah, this is what element is. So,
O of 1.
and what if update at index? Update at index. How much this will take?
O of 1.
O of 1. And what if? So take it. Leave it. So this is order of 1. Sort. What's Suganya? You tell me. Or Nikhil, you tell me. Sort. How much time sort will take? Nikhil.
It depends how you're sorting again, right?
Okay, so we'll take the best one. Okay?
N log n. N log n.
Nice. Yeah, nice. So this is what the time complexity of all the operations in array is. There are multiple other operations we're not talking about, like find max, find min. We can have any custom operation we can do, but these are basic operations which we want to perform in any other data structure in your life. So these are time complexity. This is one of the simple data structure. We don't have to worry a lot about it. We'll talk about how for each of them for more complex data structures, but just keep in mind, and this you know as well, I know. So yeah, done with the array today. Just we'll take one more question about this question is, yeah, this is also good question. Can you see this? Assume you have a method is substring. Given two substrings S1 and S2, write a code to check if S2 is a rotation of S1. Do you get the question? Given two strings S1 and S2, write a code to check if S2 is a rotation of S1. What does this mean? S2 and S1, suppose S1 is A, B, C, D, E, and S2 is C, D, E, F, A, B. So here S2 is rotation of S1. Do you see this? That we have rotated it anti-clockwise 2 times. Huh? So this is what it means. And you have tell me given string S1 and S2, is S2 rotation of S1 or not?
Praveen, so you have just shifted the bits, right?
Yes, we have just shifted twice. We have rotated twice.
Okay.
And you have tell me, I mean, I have not rotated, I'm just saying these are 2 values. If you tell, is S1 rotation of S2 or is S2 rotation of S1 or not? Just how will you do that? How will you check?
We can do that same way. Hello.
What will do?
We can say we shift it, and then we can one sec. Okay, let me think.
Yes. Santosh, you have anything?
No.
Okay.
Praveen,
Yes.
what we can do is we'll pick first element from S1
Huh?
and we'll start traversing in the S2.
Okay.
And whenever we'll find the first element of the S1 in S2,
Okay. Okay.
then we start
Yes.
shifting one index, and when we'll reach end of the S2, we'll go to the starting index of the S2 and we'll continue.
Okay. Okay. So people, he has a solution, and you also, at least someone give me a brute force approach, if not the best. Just tell me, if someone who is not a computer science engineer, what will he do? Usko maine, suppose I gave him this string, these 2 strings, I want him to tell me, is it rotation or not? What will he do? So we have to check if S2
The substring of S1. First, we'll find out whether S1 or S2. First, we need to find out whether any of the case matches as substring.
any of the
Like A, B, C, D, E, F. I will take starting 3 characters from S2 or some characters, and we'll find out whether it is a substring of S1.
I didn't get.
No, we'll try to find out whether S2 is a substring of S1.
S2 is a substring of S1.
Means not entire character, at least we'll take starting 1 character, next move to 2nd character and 3rd character, like that. So if you consider C, D, E, F, the starting 4 characters are substring of S1.
Okay. Then?
So once we find out, the next thing is again.
Then what we'll do? You have found the CDEF is a substring. What after that? Okay, you think the solution. Suganya, you tell me, what do you think?
I will first check the corner cases that if the strings length are equal or not, if the characters are equal or not, I mean their anagram or not, all these things we need to check first, then we can move on.
Yeah, base cases, you at least these things will solve for base cases, but not the generic case. Tell me about the generic case. Like what will you generic algorithm? Of course, you have to check the size. Of course, it has to be anagrams. That is okay.
Then again, Praveen, remaining AB characters are left. Then I will check it out again. AB is a substring of S1 again. Yeah, anyway, I'm going to get AB is a substring of S1. Then we can say that it is a rotation.
Okay. What if S1 was still C, D, E, F is a substring? Yes. AB is a substring? Yes. Is this a rotation? No. Okay, let me think for you the brute force method, the most trivial method, the most simplest method we at least you should come up with is, okay, I'll go through the, I'll traverse S2, I will traverse S2 and I'll check where is that present in my S1. So I'll see where the C is. Is there any C? Yes, there is a C. Then I'll go ahead, CD. Is there a CD? Yes, CD. I'll keep on doing a matching. I'll match one by one. If the moment we have matched the maximum, okay, C, D, E, F, we have matched, completely matched. Now, but so that matching, we know at least my S1 would for sure it is containing C, D, E, F. Then these two are rotating somewhere here. But we know we can't even ensure that. Suppose this was C, D, E, F, but something after that, then we can't say, yeah, we can't do that. Okay, the next brute force approach is, I will rotate S2 every by 1 and compare. Rotate one more time and compare. Rotate one more time, compare. So I'll rotate it n times, and at least one of them will match with S1. The moment it matches, yeah, it was a rotation. If it did not match, even after n rotations, this means it was not a rotation. Is this a solution? A brute force approach? Just rotate every time. Keep on rotating one by one every time match. So it will become rotate one more. It will become D, E, F, A, B, C. Is it equal to S1? No. So rotate one more time. Is it equal to S1? No. Just keep on doing this n times, and n times we match. And this is work. This will work for sure. This will work. What is the problem? What is the time complexity of this thing? What is the time complexity of this solution? Brute force solution?
O of n
Of
n.
Order of n square.
Sukanya, you tell me.
Yeah, big of n square, because we are checking two strings, traversing here and checking in the other string.
Okay, so every time we rotate, that is order of n. Every time we rotate is order of n, and sorry, wait.
No.
So here, yes, tell me.
So in the first iteration, just we have to shift the string 1 and then compare with string 2. The second,
Yes, so,
we are going to iterate over n number of times. That's it, right?
but for every iteration we shift, and again shifting is not as simple as you think. Shifting is like bring D to E, E to F, E to D, F to E, A to F. That shifting is a n time operation. It will take n time to shift it even by single place. If you're shifting, it will take n time. So you're doing this n time shifting. So it will take n square.
Okay. Yes. N square.
Okay, time's up now. You think about a better solution. We'll discuss in the next class. I will, for sure, this time I'll give you more questions. We have lots of time this time, 5 days. And on Saturday, we'll meet again with the solution of this question. I'll add more questions, of course, to the Facebook group, WhatsApp group, or to the email thread. I'll make sure I'll do it today. And I'll share the videos. I'll give few questions. Okay. And I would expect you to solve that every day.
Okay.
I'll try to give 1 or 2 questions every 1 or 2 days. Those who are interested can keep on solving and send me the solution on WhatsApp or email. I'll give questions there. Now, if you have any question, you can ask me. And people who have long questions can stay after the class. If you have small question, just ask and you can go now. If you have big question, you can ask me later.
So we have classes on Saturday, Sunday.
Yes, Saturday, Sunday, 9
I
to
mean, I have
11.
a couple of three
Yes.
questions.
What, Nikhil? Who has question?
Yeah, I have a couple of questions like from
Yeah,
previous
Nikhil will
class.
take it later. Nikhil will take it the last when everyone has left. Okay. Others. No
Okay.
question. Others, no question. Nothing. Okay. So try to. Yes, Sukanya, anything?
Yeah, my question is, when any question is asked in the interview, then how should I approach? In the beginning, you said you have to ask certain questions regarding my doubts and examples, etc. After that, how should I approach? If I know the answer, should I directly move to the best solution? Like today, you gave the known question, duplicate. So should I move to the best solution, or should I move with the, like if I move to the best solution, they may think that I've learned the answer and all.
So I don't have. I'm telling you, I don't have a very best answer for this. What should you do? What I do, I'll tell is, but because this depends how smart you are in bluffing. I mean, I give this answer to Santosh as well. So what happens sometimes, you have to be ethical. You can't be bad, like you know solution, still you're trying to fake it. That's the problem. But thing is, if you tell the correct, yeah, I know the solution, then the expectation of the interviewer is so high that he will expect you to write the exact working code there. If you make even single mistake, then he'll say what kind of person he is. Even if he has seen the solution, he's making mistakes. What kind of person? That's why I don't say that I know it. I just try to solve normally. I try to tell him the base, the brute force approach. Then I try, okay, so okay, this approach has some problem. Let me think something better. Then I think the better solution. Why would someone choose the better solution? So I tell that also. Okay, I think we should use this because that will be helpful. Oh, now so that I come up with that, and I have learned that requires special skill. I'm telling you, if you try to fake in front of a smart interview, he'll catch you, and then that will go negative. So you have to be very, either you know the solution very well that you can exactly write the best code in front of him without any hesitation and all, then you should not tell. Then you can go ahead with you can say, yeah, I know it. If you know partial solution, don't go ahead and tell you know. If you just think, yeah, I have seen the solution, don't tell. If you have written the code sometime, then only say, yes, I know this. If you have not written the code, don't say yes. Just try to go ahead, tell the brute force, tell that the bad thing of the brute force, what is the problem with the brute force, then tell I think we need something like this to solve the problem, and then come with the problem. But if you have written the code sometime, if you are very sure you have written the code, you have ran that code that sometime, then only you can tell, yeah, I know this. Otherwise, don't try to tell that. This most of the time it goes negative. It happens that you say, yeah, I know it, and then you get stuck later. Oh, I am not sure what is that. So that's why. Okay. Depends how much confident you are.
Okay.
Yeah.
Thanks, Ravi.
Okay. So one more thing, like the way I'm teaching, I'm just trying to ping me on my phone number, my number I've told that day only. What is that you think I can improve? Okay, something like, okay, can you do this kind of way? Not in high level, just change the way of teaching. That something like your voice not clear, you speak a little fast, or few things like you don't write a lot of code here. You waste time on writing code. Something like that. You can just tell me anonymously or by sending anything. You can tell me. I'll try to improve that. Okay.
Okay.
Chalo, if you're done, you can leave the meeting. Nikhil, I will talk. If the rest of you can leave if you want. I'll try to share the video of this class. I'll try to share some slides. I'll try to keep on sharing some questions on every day or alternate day, depending upon questions I have. Good questions, okay? And we can discuss on the threads, email threads, and WhatsApp group. Goodbye. Please, people, you can leave. Yeah.
Praveen, here, can you scroll up? I have one question. Wasn't there?
Yes.
Yeah, here we are giving space, right? Once we get the new length, we are giving some space, extra space there. How we are giving the extra space means we need to iterate or loops and get some extra space. at the end, or what is
Yeah,
the best?
we ran a loop a number of specific times, and we just made, okay, we know the length I, suppose the length is j, so str of j equal to /0, str of j plus 1 equal to /0, str of j plus 2 equal to /0. We just ran a loop for number of spaces, and that many times we appended space.
Okay, for the existing string itself we are doing, right? Okay.
Yes.
Is that possible? I'm thinking. See, once, okay, they are going to give string, then we need to convert string to string array. That's correct, right?
Not string array, but a mutable string, not string array. But you don't have to convert it into string array. String array is like Praveen is single string, is a single string, teaching a single string. That is the point in time you want to use string array. Why you want string array? This is a character array. This is a string character array.
Okay, then how to add the extra space is just character dot string dot character, some empty space like that. I need to add.
This is again language dependent. If it is a Ruby, we can in Ruby we can simply do str of some j equal to something, and this works in Ruby. In Java, I think you can do this. Once you have this your new string length, you can change by mutable string buffer and everything. You can change the size, and then you can do this in Java as well. So you can do this simply run a loop, number of a while. Number of spaces is less number of spaces is more than 0. Just str of I plus 1 or leave it for I equal to 1 to I less than number of spaces I plus str of I, where I is the length, original length, equal to, just keep on doing this. That's it.
Yeah, then yeah. Okay, then yeah, this is my question.
Okay. Okay, Vasanthi.
Thanks, Praveen. Okay.
Thank you. Yes, sure. Nikhil.
Yeah, Praveen, I have 3 questions. So the first question is that.
Yeah. Sorry, I couldn't call you yesterday. I was a little busy. So tell me. Yeah.
Yeah. No, it's fine. Yeah. So that the one like you discussed in the demo class where you made everything negative, you made each number negative. That one you went a little too fast, so I didn't get it here.
Okay. Yes. So let me ask the question once again. So the question was given an input of integers, given array, suppose array A of integers, which is like this. Okay, so this was a question, and you have to tell me, does it contain duplicate integers or not? Does it contain duplicate numbers or not? That's what the question is. How will you solve this duplicate?
Okay. I can sort it. I can sort the array.
Awesome. So that will work. You can sort the array, and then
yes.
And then after, yeah,
and then
after
count.
sort, yeah. Okay. After sorting, what will you do?
Then you will, if it is more than on the count, you count how many are there, right? Once you sort.
No. So once you sort, you just have to iterate once again. You have to iterate once again, one by one, and just compare the consecutive element. Oh, is it same? Is it same? Is it same? The moment the consecutive elements are same, we know, yes, duplicate is there. Because without sorting, if you want to check if duplicate is there or not, what we have to do is take one element and search in the full array. Where is it present or not? But that's not the problem with sorting. In sorting, if it is same, they will be next to each other. Because they're same, they will be next to each other. So that's why we sort. We take the benefit of sorting, and after sorting, we can simply check. Okay. If I am present twice, my value will be just present next to me. Otherwise, it won't be there. So 2. If 2 is repeated, then of course there should be one more 2 after 2. If otherwise it won't be there. So no, it's not repeating. So after sorting, what this becomes is this. After sorting this, what does this become? This will become 0, 1, 2, 2, 3, 4, 5, 7, 7. Okay. Now,
Yes.
now I can just take my first index 0. Is it repeated? Is it same as next? No, so it's not repeated. 1. Is it same as next? No, it's not repeated. 2. Is it same as next? Yes, it is. So this means 2 is repeated. The moment we get this, we can easily say, yeah, it does not contain duplicate. It contains duplicate element. Okay.
Okay.
But
So
this
in
solution,
this case,
in this case, what is the time complexity?
it will depend on the sorting algorithm again, and then while comparing n.
So what will the time complexity be? Assuming we are doing quick sort, what will the time
n
complexity
plus
be? How much?
n log n plus n. N log n
Awesome.
plus n.
Awesome. So and which will be equal to?
Which will be equal to n.
No, which will be equal to n log n. So this will be equal to n
Oh
log
yeah,
n.
in the worst case, n log n plus n.
Yes. It will be n log n plus order
n.
of n, which is equal to order of n log n, because n log n is of higher order than n. So it will be n log n.
Oh yes. I confused between log n and n, and log n.
Okay. Yes. So
Yes.
now comes another question. Can we do it better? Can we do it in even better time without using extra space? We're not allowed to use extra space. I would suggest you have the hint of doing this minus thing. Okay, you have the hint of doing this minus thing, and you also have the hint of today's string one, the string question which we did in the first question. Find duplicate in the string. That was is there all unique or not? Use these two as your hint and try to solve. Try to think. We will discuss it before the next class. Okay, you have two hints. One is negative, make things negative, which I discussed with you in the morning. Now also the second hint is for the string, unique. You find all unique or not. So use those two things to find a solution, and you have to do it in order of n.
Okay.
Okay, and the catch here, one more catch. I'll tell you catch as well. The catch here is the numbers in this array will be in the range 0 to n minus 1. 0 to n minus 1. Okay, that's the number. All the numbers are in this range. It won't. There is no number which is bigger than this. That's another catch you have to keep in mind. Keeping this catch, keeping the hint of morning question, keeping the hint of minus 1 and indexing. Try to solve. You should be able to solve. Okay.
Okay.
In order of n.
Okay.
Okay. Thank you, Nikhil. If you have anything else, tell me. Otherwise, I'll leave.
Yeah, I have two more questions. So the next question is when we are considering runtime, right? Say we have 60 n log 60 log n. Okay. That is equal to log n raised to power 6, right?
60 n log n. What about 60?
No. 60 log n.
60 into log of n.
60. Yes.
Okay.
That is same as log n raised to power 6, right?
Log n raised to power
6.
60. Why 6?
Sorry, 10 into log n raised to power 6. This is 10. Yes.
Okay. So what? Yes.
So which these are equal, right? So which one do we consider? So when I'm saying the runtime of an algorithm is say 60 log n, 60 log n means also 10 into log n power 6. So which n power 6? So which one will I take?
Yes. So see, at then we have to get rid of all the constants. So this has this constant. This is k into log of n. Okay. So at then this will become log of n.
Yes.
Okay. Now this thing also it has two constants. K1 into log of n to the power k2. So this is again becomes log of n only. See, whenever you think 60 and problem with 60 and 10, just think n as 1 million or 1 billion. Then these 60 and 10 and 6 does not matter at all. These will become very small factor. Okay, sorting 1 million number and sorting 6 million number has almost same time complexity. That's why we do not want to consider these things when we talk about time complexity. We do not. This is n to the power 6. First of all, you had confusion among these two only. These two are same. These two are same. You only told these two same. So we should not worried about these two. Like, just try to reduce it as simplest form as possible. So simplest form is this only. This is simplest form rather than this. So let's not talk about this case as well. I mean, we can. There is a way to find the final answer from this also. Okay, if this is what this is equal to k1 into log of n in power k2, and then it will be equal to log n. That we can do, but I would suggest try to reduce to simplest form, and the simplest form this is this only. This is the simplest form, है ना?
Yes.
So
But what I
now
thought, what I thought is, if you do using math, you can make this as log n power 6. So log n power 6 is a higher complexity than log n. So I was wondering, how is it equal?
Yes,
Meaning, what will you take when you get it?
What I know. So see this. This is million. Suppose a million something like that. To the power 6, and this to the power this. Both are same for us. Okay, they're in the same order. They're in the same range. They might not be equal, but they're similar. So we talk about similar here. We never try to think in terms of very equal or not. We just try to ignore the constant as much as possible. And normally while giving the time complexity, we always try to take the n as million or billion. Then your constants k1 and 6 and 10 has no value in front of million and billion. Okay.
Okay.
Yes.
Okay, yeah. The graph of log is like it gets constant at one point, very high numbers.
Yes.
Okay, and the next question, Praveen, I had was in doubt in insertion sort. So I am confused how the in that for loop, in the second for loop, like how are we writing the I and j terms?
So insertion
So
sort.
could you just walk me through like fast over insertion sort?
Yes. Okay. So I'll take a mid case. This will be very easy to explain to you. If we take a mid case. Mid case is, suppose we have somehow we have sorted our number. 0 has come here, 1 has come here, and 2 has come here. Okay, and the rest of the array is still unsorted, which is like this: 5 and 1 is gone, and 2 is gone. Yeah. Suppose this is the case. We have somehow sorted till now. Okay. Now we come to this element 5. Now we come to this element 5, and we check where should 5 go. We start from the beginning. We check, can it go here? No. Can it go here? No. Can it go here? No. Can it go here? Yes, it can go here. Let's try to insert 5 here and remove from it, which is same. Let me take some weird case. This was suppose 0.5. Now we come, we have already sorted till here. 0, 1 to 5 is already sorted. Now we take 2.5. So we check, can 2.5 be inserted here? No, it cannot. Can 2.5 be inserted here? No, it cannot. Can it insert here? No, it cannot. Here, yes, it can be inserted here. That's what insertion sort. We are trying to insert a number to its proper position. And proper position of what? Proper position of the already sorted part. And this is the already sorted part here, and the proper position of 2.5 in this sorted part is this. We'll insert here. Okay. Now we inserted it here and we remove from here.
Okay.
Okay, so this
Yes.
thing, this thing is done, and we have our thing sorted till here, and this is still unsorted. We try to sort this as well now. Now to write a generic code for this is like for I equal to 0 till I less than uh,
N
yeah, wait,
n minus 1 or n.
whatever, I less than n, I plus plus. What we do is we insert a of I into so what I'm doing here, we are maintaining this sorted part index somewhere. Okay, we are maintaining this somewhere 0, and we'll keep it changing as well. Okay, after we insert this will increase. Okay, so what I'm doing is insert AI in between 0 to sorted part index. जहाँ तक sort हो गया वहाँ तक कहीं भी डाल दो. This is what we're doing here. I will write a code for this, but this is a very modular thing to understand. For every element, take that and try to insert that element a of I in between 0 to till sorted part, and then increase the sorted part. Now this part will take you n time. This part is inserted not so simple. It's like putting it here and then shifting, putting it that place and then shifting as well. है ना?
Ah, yes.
Okay, so this will take order of n, and this external loop is also n. This will take a total of n square. है ना?
Okay. Yes.
Okay. Now you can go ahead and try to write the code. I'll verify. I don't have like time. I have to leave also, so I don't have time to implement that code here.
Okay.
But I would suggest, even if I had time, I would suggest you to write the code. Okay.
Yes, I will do that. And Praveen, one more thing. Can you just share me all the video and the slides, like just for material, like yesterday's and today's videos and slides?
Yes, I'll do that. But once I have the email, I have your phone number at least. I can do for you. Sure, I'll do for you.
Yeah, I'll message you my email ID.
Okay. Cool.
Yeah, cool. That's it, Praveen. Thanks a lot.
Thank you. Bye. One more thing. Hello.
Yeah, bye. Yeah,
So you
yeah, Praveen.
So you have deposited the money in Dhaval's account?
I in Dhaval's, Pooja's.
Okay, Pooja account. Okay. Nice. Thank you. Thank you, Nikhil. You can leave.
Yeah.
Bye.
Okay, thank you. Yeah, thanks, man. Yeah, bye.